In 7.2.1b, we have it on a variable x, and we're going to say, let's say we want to take two data values, x1 and x2, and we'll use this to get an estimate of x. Now, there's many different ways you can come up with estimates. Yes, the most common one we do is the average, but it's not the only way you can do it. And so in this section, we kind of go through and kind of make up some random looking estimates so you can practice finding properties of them. So you can find the expected value of them, you can find the bias, we can find the variance of them, just because we're trying to teach you the underlying concepts. I'm going to do the hardest one here, so you can do the other two on your own. But we want to find the variance of this estimate, which is a mu hat 3. Just telling us it's the third estimate, it has a hat on it, so we know it's an estimate. Okay, we want to find the variance of it. To do this, you have to go back to your variance rules from section 2.6. When we learned about things like the variance, if we have the variance of ax plus y plus b, let's kind of do a general case. If you have a number in front of like this x, it comes out, but it comes out squared. Then we take the variance of x. Now, if you have different pieces, you just take the variance of each one. So plus the variance of y. Plus, now this b, when it comes out, it just comes out as a 0. Adding the same number to every value doesn't change your variance. So does that look familiar? You pull out your coefficients squared, take the variance of each piece individually, and if you are just adding a constant, it doesn't affect the variance. It just comes out as a 0. So let's try that for this problem. We want the variance of mu hat 3, but that's really the variance of x1 over 6 plus the variance of x2 over 3 plus 9. So let's see what happens here. So I just took the variance of each piece up here individually. Now the 6, it comes out, but it has to come out squared, so it's going to be 1 over 6 squared times the variance of x1. The variance of x1 is 10 plus the variance of x over 3. Well, that 3, or 1 over 3, comes out squared times the variance of x2, which is 15, plus, and then the, oh, sorry, I said plus 9 here. That needs to be plus 0, because the 9, when it comes out, is just gone. Put this in your calculator, and you get 1.9444.